कोई बटन लगी है।
हेलो मोहन सर, गुड मॉर्निंग। हेलो
आए जा रहे हैं मतलब वो के
Hello everyone. Warm greetings from Aryabhatta Group of Institutions, Ajmer. I welcome you all in this international webinar on educational challenges in the epoch of pandemic beyond traditional engineering to cyber physical system, organized by Computer Science and Engineering Department. I request All the participants kindly mute your audio, stop video and don't present your screen. So, before moving further, I would be glad to introduce Aryabhatta Group of Institutions, Ajmer. We have completed 16 years of glorious excellence. Aryabhatta Group of Institutions comprises of 3 colleges and 1 senior secondary school. First one is Aryabhatta College of Engineering and Research Center, Ajmer. Second one is Aryabhatta College of Management, Ajmer. Third one is Aryabhatta International College of Technical Education, Ajmer, and Aryabhatta World Senior Secondary School, Ajmer. We offer courses like BCA, BBA, BVOC, MBA, MSc CS, MSc IT, PGDCA, BTech, MTech, Polytechnic, and this year we are coming up with new degree and diploma courses which are actually very prominent courses nowadays. These are robotics and automation, data analytics, hotel management, network security, Python programming, and D-Pharma. Participants, today we have with us Dr. Munesh Chandra Trivedi sir as our keynote speaker, and as resource person we have Dr. Mohan Lal Kohli sir, Professor in Smart Grid and Renewable Energy, Department of Engineering Science at University of Agder from country of Midnight Sun, Norway. Now, it's time to introduce today's keynote speaker, Dr. Munesh Chandra Trivedi sir. He is currently working as Associate Professor of CSE at National Institute of Technology, Agartala, Tripura. Previously, he was Associate Professor and HOD of IT Department at Rajkiya Engineering College, Azamgarh. He also handled the additional responsibility of Director in Charge at Rajkiya Engineering College, Azamgarh. He has a very rich experience of teaching the UG and PG classes in government institutions as well as prestigious private institutions. He has published 12 textbooks and 108 research paper publications in different journals of international repute. He also edited 21 books of Springer nature and also written 23 book chapters. He has received numerous awards including Young Scientist Visiting Fellowship, Dronacharya Award, Author of the Year, Man of the Year, Best Senior Faculty Award, Best Scientist Award, and Vigyan Ratna Award. He has organized more than 30 international conferences technically sponsored by IEEE, ACM, and Stringers. He has delivered numerous invited and plenary conferences and technical sets in conferences in India. He is also member of editorial board of International Journal of Computer Application, Journal of Modeling and Simulation in Design and Manufacturing, and International Journal of Imaging and Engineering. He is also associated as member of Board of Studies as well as in syllabus committee of different private Indian universities. Now, I would request Dr. Munesh Chandra Trivedi sir to introduce our today's resource person, Professor Dr. Mohan Lal Kohli sir.
Good afternoon, everyone. And it is our proud privilege that today we are going to hear one of the renowned professor in the field of IoT and renewable energy, Professor Mohan Kohli. He is a very close friend of mine and he has developed many real-time software for the Norwegian government and many European countries. He is full professor in energy system in the University of Agder, Norway, and he has more than 25 years of academic experience at the international level. And he has worked in many countries and in many universities. In terms of research and teaching, he is the excellent professor. He has done many innovative projects and real-time projects for the Norwegian government, for the European country. So it is our proud privilege that today we are going to hear such a renowned academicians and who is really worked very hard and who is really developed a real-time software in the field of IoT, in the field of energy system. Now I request Mohan sir kindly inspire us with his knowledge and wisdom. Mohan sir, please.
So, thank you very much, Manish. So, are you able to hear me, Manish?
Yes sir, yes sir.
Very good. Yeah, because I put my presentation on my PC or computer, and I'm using the mic and the speaker from my mobile. So that's why I tried to check it. Okay.
Thank you sir for giving the opportunity and time in such a busy schedule. Thank you sir.
No problem. Good. See my screen?
Yes, yes.
Good. So, thank you very much for giving me this opportunity to talk with all of you on education challenges in epoch of pandemic, and during this situation, how we have to change our traditional engineering education approach to cyber physical system. That is the key theme or the key topic which I would like to discuss with you. And Manish and already the moderator, they have given my background. So thank you very much. So as we know, in this situation, it's really challenging to deliver the online education also. And we have to think how we have to make proper changes in our traditional engineering education system, which should be based on cyber physical system. So as we know that we are moving from one evaluation to another evaluation. If you consider, let's say how our 18th century education system was that. Our 18th century education system was based on Industrial Revolution 1, where the education system, it was based on physical labor, basic engineering, and learning skills. And now we are moving towards the cyber physical system, where we have to integrate Internet of Things. If we come from Industrial Revolution 1 to Industrial Revolution 2, which has started at the start of the 20th century, that revolution was basically based on electricity and mass production and how we have to utilize the expertise of the working force. So considering those points, the talents which were required for Industrial Revolution 2, it was like how we had to develop the business, how we had to reduce the screens as a risk, how we had to do the standardization, how we had to do the certainty into the system. So the competency which were required for Industrial Revolution 2, it was quite a mix of the business. Then from the earliest 70s, due to the automation and penetration of softwares and the computer system into the manufacturing, we changed our education system where we need to have more deep expertise in and how we have to integrate the multidiscipline together, and more focus was on science, technology, engineering and mathematics. So at this moment we are in the phase of Industrial Revolution 3. But now, due to the pandemic situation, we may need to move towards the Industrial Revolution 4, which is going to be based on cyber physical system or Internet of Things. For that, we need to have the talents which have more adaptability, learning agility, empathy, and transdisciplinary approach. And this fourth industrial revolution, which is going to happen due to the present situation, we may need to make a revaluation in our education system also. So at present, our traditional education system is more like based on Industrial Revolution 3. But considering the cyber physical system, when we want to change our education system, we have to see that how we can utilize the resources or the academic knowledge of the experts from different parts of the world. So that is going to be a big challenge. And in this fourth revaluation, which we can call as Education Revolution 4 also, where we have to see how this integration has to be included in our curriculum also, and based on that, how we have to divide or how we have to make the policies for developing our new education system. So then I'm going to give you little background of the Industrial Revolution 4, and after understanding this Industrial 4 revaluation, we have to consider that how we have to change our education system. So if we see this slide where I have included the different components of the industries together, and those all different components, they are integrated with each other through cyber physical system. For example, if we consider any manufacturing industry, so that manufacturing physical system is not available at that location, he is available at another location. So how he can, or how he or she can change the design specification of that particular product from anywhere in the world. So this is going to be the cyber physical system. So here you can see that how we have to integrate the different geographical locations with the specific expertise in Industrial Revolution 4. So now I will take another example of the energy system here. In the energy system, you can see that we have too many power generation sources. For example, wind, solar photovoltaic, conventional power plant, and so on and so forth. And we know that these intermittent renewable energy sources, they are producing the energy based on the nature, okay? But we want to have the constant power output or constant power at the industry. So how we have to manage or how we have to utilize the cyber physical system for overcoming or for buffering the intermittency of renewable energy sources. So in that scenario, we have to consider how the conventional power plant or controllable power plant can adjust their power output with reference to the change in the intermittent renewable energy sources which are located at another location. So here you can see that we are going to utilize the different geographical location components, okay, or their or whatever the sensors and actuators we are putting there, how they are cooperating and how they are providing the information to the conventional power plant, which is again located at another location for providing the constant power to the industry or within the distributed network, let's say. So this is really a big challenge. So when we want to change our education system beyond traditional engineering to cyber physical system, then we need to make a lot of changes in our curriculum, and also we have to consider that the teachers or the professors who are going to teach or who are going to train the next generation professionals, how they have to get updated themselves with a different type of knowledge or with upcoming knowledge, and at the same time to have the adaptability to learn from the students also or from the and professionals also. So that is a very key point in the cyber physical system based education also. So now we will move towards the new point, and now here you can see that I have included some different emerging research in the cyber physical system. In the cyber physical system, a lot of have all have not been implemented into the education system. So here I did some little survey about the research based on cyber physical system in IEEE. So here you will see that there are a lot of research work has been happening. For example, if we take the case of the autonomous vehicles, okay, that is also going to be a part of the cyber physical system. So here you can see that more than 30,000 articles they are available into the IEEE. Then if you take about the system integration, which is again a very key part for the industrial revolution 4, where we are going to integrate different technologies from different places. So the research articles are more than 110,000. Okay. Then if we consider the cloud computing, which is again going to be a key part for the industrial revolution 4, there we have more than 45,000 articles. And then Internet of Things, that is again the key component. Okay, so here you can see that more than 110,000 articles are available. Then if you compare, if you come towards the manufacturing or 3D manufacturing, for example, so then the articles, they are available around 10,000 or more than 10,000. Autonomous robots, more than 150,000. Big data, more than 110,000. Augmented reality, more than 30,000. Cyber security, which is a critical part, more than 50,000 articles. So here you can see that. So for the industrial revolution 4, based on cyber physical system, lot of research have been already completed or ongoing. But now it is a proper time that how we have to integrate this research into our education system, or how we have to change our education curriculum or education policies in this using traditional engineering approach, or on the base of the traditional engineering approach to make further more based on cyber physical system. So here in the left side, I have taken 4 examples of the cyber physical system. One very good example of the cyber physical system is the healthcare or medical system, right? So here, those who are from the medical professionals or pharmacists or medical technicians like that, so for them also there is a lot of opportunities for changing their education curriculum or integrating this cyber physical system into the healthcare. Then if you come to the industrial or IoT system side, so here you can see that there are lot of our big scope which is going to be related to the industrial revolution 4. So here you can see that how the information flow is going to happen or going to help in the industrial revolution 4 with the physical sensings. So here there is a integration of both information flow and the physical sensing through the cloud computing or through the cyberspace, and how we can modernize or how we can develop our industries based on industrial revolution 4 or considering the cyber physical system. Then if you come to the transportation system, so we know that transportation system is also becoming autonomous. So, and at the same time, we need to know all the information, including airspace or ground transportation, or the shipping also, or the marine industries also. So all those transportation system is also going to work through the cyber physical system. And then we have to see that how we can utilize the receiving information and how we can do the cloud computing on those information and provide the appropriate information to the transportation system using the cyber physical system. Then coming back to the energy system, which is a key part or the key component for today's lecture, which I'm going to share with you some typical examples on the energy system is from smart. You can see that what I already earlier I mentioned that there are so many intermittent renewable energy sources and the conventional power plants, demand side management, electric vehicles, and so on and so forth. So how we have to integrate them through the cyber physical system and operating them in the uniform way for developing intelligent smart grid or intelligent power grid. For that purpose, we need to train our next generation professionals to whom we can give the proper input based on cyber physical system or based on IoT things, and how they can contribute effectively towards the industrial revaluation board. So that should be our main approach, and we should consider that in our education revaluation 4, or maybe in a simple way in developing new education policies. We have seen that at this moment, due to this pandemic situation or COVID-19 situation, most of the students and working from. So we have to use the cyber system for integrating them. For example, let's say Munesh is sitting in northeastern part of India, and your college is, let's say, is located in the Rajasthan part. I'm located in Norway, and we want to utilize each one's expertise. And we know that under this present situation, it is really difficult to travel also. So, I mean, whatever the expertise I have and whatever the expertise Munesh have, how they can contribute, how these expertise can be utilized in the education system at the Rajasthan. Let's say Munish is having expertise in the field A, I'm having expertise in the field B. So how this both expertise of the field A and field B have to be provided to the student, right, to gain their knowledge in Rajasthan, for example. And then when students gain the knowledge, so when he's doing more study on that, so he may gain more knowledge compared to Manish or me. So then how I can get benefited from that student also, that approach also we have to consider. So basically, this cyber physical system or education revolution code, it is going to be effectively contributing towards the lifelong learning process also. So now coming back to the next slide, where I have taken the example of cyber physical system in the smart energy system. So if we want to work on the smart energy system, so there are a lot of points or a lot of things which we can consider and where we can integrate multidiscipline engineering together. For example, we need that we have to have energy conversion system. So we need to have the expertise of the control engineering. And again, when we are going to control the energy conversion process, okay, so the controller can be controlled from or operated from any other locations. So that is again a very important point. Then regarding the power generation, we have to consider how the conventional power plants can be incorporated with intermittent renewable energy sources for providing the reliable power supply or reliable and secure power supply in the distributed network. So that is again going to be based on the cyber physical system. So let's say if you want to develop the electrical energy curriculum, for example, in the education evaluation board, then we have to consider all these points in developing our curriculum or providing the knowledge or training to the next generation professionals. So in the same way, when we are talking about the smart energy system, so the key point is the protection system. or not only in the energy system, we have to consider the protection system, but the protection system is a key point for any other system, including its industries or the transportation or even the healthcare system. So here, based on a particular specific application, we have to consider how the remote location faults can be controlled using the cyber physical system from a remote location. So those type of approaches we need to include in our education system. Then again, in the smart energy system, very important point, that is the electric transportation or sustainable transportation vehicles, like hybrid. So electric vehicles. So we know that in many countries, the electric vehicle penetration is increasing exponentially, and they are creating some problems within the distributed network due to increasing demand. So we need to work then how we can have the coordinated charging of the electric vehicles within the distributed network, so to provide or to make the balance of the demand and supply. So here you can see that we are going to utilize not only the traditional engineering approach, but also the geolocation approach also, and the availability of the power or the energy within that area, and how we can make a proper balance based on the customer need and based on the availability of the power or the energy within that particular area at that particular time. Then another very important point is the control system, that is power system control, overall control. That is again very interesting. Then a smart energy system which is going to happen through the microgrid. So within the microgrid, to make the appropriate demand side management, integration of intermittent renewable energy sources within the distributed network, for example, roof-mounted solar photovoltaic system or so on. So that is again going to be based on the cyber physical system. So here you can see that how we can utilize the expertise or the knowledge of the computer system engineering together with the electrical engineering for making the distributed network more smart and making it more autonomous and reducing the peak demand on the main grid. So then, of course, when we are talking about the microgrid or overall energy system, so we need to have the wide area monitoring also. And then at the same time, if suppose you have the good background on the chemical engineering, so then we need to consider about the energy storage or the battery, because I'm focusing here on the smart energy system. And to overcome the intermittency, energy storage is going to play a very important role, and of course the computer engineering also. So we have to consider about the electrochemical energy storage. So the chemical engineers can also effectively contribute in this cyber physical system when we are talking about the multidiscipline engineering. And when all these systems or the IoT based components, they are connected with each other, then key component is that the cyber security. So how we are going to make this whole system completely secure? So very important point is that in our computer engineering curriculum, we need to include a specific course on cyber security. So we should not bypass that. And because we know that now the technologies are changing and many people, they have the capability to hack the conventional system. So all the time we need to know to have updates about the cyber security. So here you can see that not with reference to the cyber security point of view, we are providing the knowledge or the information or the training to the next generation professionals from the teacher point of view, but at the same time teachers or the professors have also to update their knowledge, because due to the change in the upgradation system, or people are finding there a lot of flaws into the system. So all the time this has to be updated. So here you can see that the cyber security is just like a lifelong learning approach, which is going to be very important in the future education system. And in the future education system, that is going to be the education revolution 4. For example, in my university, let's say I have one system which is IoT based system, and the students from the Rajasthan, they want to learn about that system, so they can have the access to that system and they can play around that, or they can do the experiment there, and by using the facilities available at a remote location university, or for example in my university. But the information which is going to be communicated, right, it should be the completely secure. No one should be in a position to hack, otherwise we will get the bad results or not very good results. So this is just I have given one example. Then another very important point is the onboard power system, or the, let's say, onboard power system, for example in the marine applications also, or the ships, or even aeroplanes also. So that is again very important point to consider, and again it is going to be based on the cyber physical system. And when we are talking all these things, we need to have a lot of multi-level converters, and those converters again they will be based on the cyber physical system. And when we are considering all these points, then of course we need to develop some standards also. So here just I have taken one example, IC 61850, which is widely used in the distributed network for communication and operation and protection purpose. So then when we are moving towards the cyber physical system and we want to change our education system, right? So then we have to include in our education system the upcoming standards also. Okay. So now I will give you one typical example, right, of a cyber physical system of one of my project. And this project is was titled as Scalable Energy Management Infrastructure for Aggregation of Households. And this project was funded through European Union Framework 7 under the scheme of ICT infrastructure for smart grid management. So in this project, the target was that how we can utilize ICT infrastructure for managing the electricity consumption of households, considering incentive-based demand response program. So this project, it was a multidisciplinary projects and multi-country projects also. And here in this project, there were 12 partners from 4 European countries. And from 4 European countries were Norway, Denmark, Germany, Switzerland. And out of these 12 partners, there were only 3 universities and research organization. And my role in this project was as a technical manager. And here you can see that our 30th institute co-product added IoT-based components under this project. Again, it is from Denmark. Misorio, NLPN, SEIC, CSCM, NetPlus, HESO, they were from the Switzerland. And out of that, HESO is academic partner, and remaining they were the industry partners. And from Norway, University of Agder Energy and Agri Consulting, they were the partners. And here, Agder Energy, they were the utility company like the Electricity Board in India. Agri Consulting, they were quite good in testing the hardware and the software, let's say from hardware and software testing point of view. And then from Germany, Fraunhofer IWS was the partner which provided their virtual power plant facility. So here you can see that all the partners, they were located at different locations, and their specific expertise have been used, okay, in developing IoT based home energy management system in this project. So in this project, the idea was that how the cyber physical system can be utilized for controlling and managing the demand of the household, for reducing the peak demand. And here you can see in this project how the different expertise, they have been integrated together for developing a typical example of the smart grid, and especially more focused on the demand side management within the household by utilizing the expertise or the knowledge from different geographical location. So this was a research cum demonstration project. Now we have to utilize the learning from such type of project in developing education curriculum or making our education system based on cyber physical system where we can integrate the multidisciplinary engineering approach and at the same time utilizing the expertise of the remote locations. So that should be our key approach in our revolution. So here you can see that the key objective of this project, it was how we have to define the technical and functional specification, including front-end and back-end system. So considering the grid constraints where transmission system operator or distribution system operators specifications should have to be included. Then we have to consider on developing an open ICT infrastructure and architecture for implementation of a demand response function in households in order to bring together as many services for smart grid. Then how this system intelligence can be used for remote control of electrical loads in households. Then we have to, it has been considered for integration of the back-end and front-end system for verifying all interfaces which has to be operated as expected. Then not only that developing the technology or developing the knowledge, but at the same time the very important thing is that to do the pilot testing and validation of such type of system in real and user environment. So that has to be considered. And in this project, the pilot testing have been taken very seriously, and the presented system have been tested in 100 houses in Norway and 100 houses in Switzerland by utilizing the backend system from the Germany. So here you can see that in the Germany, they have the knowledge or they have the expertise of the virtual power plant, which have been utilized in the Norway and in the Switzerland for managing the power demand and considering the prediction of the load as well as the prediction of the renewable energy sources with reference to considering the grid constraints and managing the conventional power generation output. So here you can see that the expertise of one location have been utilized at location B and C also. In the same way, in our education system, we have to consider that approach to utilize the expertise of location A to the location B and C also. Okay, one institute cannot have that all expertise within their faculty or within their academic staff, right? So we have to use that proper approach, and it will help us for achieving sustainable development goals also, and making optimum utilization of the available resources, knowledge resources on the earth also. Okay, so that has to be considered very seriously. Then another point which has been mentioned here, the security and privacy. When we are talking about the cyber physical system, then the security and privacy are very important, not only for the industrial revaluation 4 also, but also education revaluation 4 also. Then when we are moving towards the industrial revaluation 4 or education revaluation 4, the conventional business models has to be changed. So here specifically in this project, there was one work package which worked on developing the business model under such type of scenarios for the utilities as well as for the customers also. Then here I have given just an overview that how this project has overcome the smart grid challenges for a particular specific application in the customer domain. So from the grid side or the market side, the flexibility has to be provided from the customer side. Okay, so that flexibility from the customer side is going to help in distributed energy resources also, in industries also, or commercial buildings also. And then it can include the load demand, energy storage, distributed generation, and buildings. If you come towards the upper side, from where we are going to get the information regarding the flexibility. So here you can see that we have the price signals, incentive-based tariffs, control signals, how that flexibility is going to be offered to the customer side, and then bidirectional information exchange also, because we need to have the bidirectional information exchange for deciding the flexibility or providing the flexibility to the customer domain. For that, we need to have appropriate approach on the how we are going to utilize the available data for the forecasting also, and developing some demand side management scenarios also. So here, then you can see that how this architecture it has been developed for this particular project, considering the cyber physical system. So here you can see that there is a front end and the back end system. Front end system, it is in a particular home, and back end system, it is at somewhere located at another location, remote location. So in this project, the front end gateway, they were at 100 houses in Norway and 100 houses in Switzerland, and the back end system, it was at the Germany, that was the virtual power plant. So here the back end system, based on the aggregation of the load household demands and the prediction of the renewable energy sources, this backend system is to provide the stochastic scheduling to the front end system, okay, and this communication or the information which is coming from the backend to the front end. In this project, it was through the 3G communication, and when we come to the front end system, so front end system is called the home energy management gateway. Let's say it is going to communicate or giving the information to the devices of power intensive non-critical devices for shifting the operation through the Zigbee communication. So here you can see that how the information related or how the knowledge related to the information communication technologies have been integrated in a specific example of the smart grid of home energy management system. So here if you come towards the right side, then here front end system, that is home energy management gateway, back end system, that is basically the virtual power plant, or it is the aggregation. So based on the information of which is getting from the front end system to the back end system, so that back end system uses that data for developing the scheduling algorithm based on the forecasting also, and considering the intermittent renewable power generations, and at the same time considering the customer's behavior or the comforts also. Then this backend system sends the signal here for the home energy management system for shifting the operation of non-critical power intensive load. So here you can see that how this front end system and the back end system, they are integrated through wide area network, okay, by taking into account the DSO, TSO constants also, and customer satisfaction also. So if we take this example as a cyber physical system, and let's say we want to train our next generation professionals like this, right? So it is going to give in your mind that how we have to change our education system, or how we have to use this approach in revolutionizing our education system. So from the policy point of view, we have to be very broad now, and we have to consider that how we have to change our education delivery approach, as well as the curriculum changes approach also, and not only just giving the online lectures and like that, but that online lectures is okay, that is also one part, but at the same time how this online approach or how this cyber physical system approach can help us for utilizing the knowledge of person A from another location to give the delivery to another location, or to enhance the knowledge of the persons who are at another location, right? So that approach we need to follow, rather than giving just like an online lectures and like that. Then at the same time, we need to utilize that what type of education management tools we are going to use. So the key component in the revolutionizing our education system is that what type of education platform we are using, and how we are going to integrate that with available expertise of from different locations or from different persons, basically, for example, and then how the student, basically he is the user of that education platform. So how he can get the benefit, and when he can get the benefit, how he can become the trainer also, or training the trainers. That approach should be there in this education revaluation 4 also. And for the teacher or the staff, we need to have the approach as a lifelong learning approach, which is a very key output from this cyber physical system demonstration project. Now come to the next slide here. So the achievements from this project is that basically in this project you can see that how the flexibility forecast services from different locations have been used as a virtual power plant. Then how the integration of stochastic scheduling have been done, how the grid constants they have been utilized here, considering the system operation constants maybe in a simple way. Then another important thing, security and privacy enhancement, and then the business models. So that basically this is more like specific to this project, but considering our education system, we have to make a very broad or very high level thinking, like how we have to change our education system, let's say by taking this one of the example of this cyber physical system. Now here, this is a very interesting slide which I have correlated with industrial revaluation and education revaluation 4. So let's say if we consider the industrial revaluation 4, which I have mentioned in the slide number 2, to the education 1. So that education 1, it was more like a teacher controlled education. So whatever the teacher is saying, the student has to follow like that. So that one was the approach as an education 1. I can say basically it was based on industrial revaluation 4. Then if we come to the education 2, so here that how it has been considered, it has been considered learners as a recipients of the knowledge, okay, and then they are using that knowledge in the field. Then if we come to the education 3, which is basically is ongoing now, or many countries they are trying to adopt that also. So that education 3 is again it is based on industrial revaluation 3. So that is again it is based on the project based learning also, collaboration, social networking in the academics, access to everyone, and collaboration with others to the computers and like that. But now we have seen that due to the pandemic situation and other situations, we need to change our industry. We have to move towards the industrial revolution 4. So naturally, then we have to move or we have to change our education system to 4 also. So then education 4, how it is going to be there? So the knowledge of experts, the experts which you have the specific domain knowledge, everyone should have the access to that. Then the learners, they can also become the teachers, okay. And then we need to have the educator and resource guide also. Then we need to make that the web as a curriculum or web as a service there. Then learn as content producer and the sharer, that approach has to be there. Then learner as connection maker also, because let's say I have knowledge of one, then how I'm going to connect to each other. And of course, because in this the education should be free to all, so it should have the open access of information, okay, so that other people can get benefit of that. So here you can see that how this slide is going to help you in understanding the revaluation of education with reference to the industrial revaluations. Okay. Then coming to the next slide here, how we have to develop the platform for the cyber physical system based. So of course we need to have the basic computing concepts. We need to know the computing for the physical world. We have to have very in-depth knowledge about discrete and continuous mathematics also, cross-cutting applications for sensing, actuation, control, communication and computing also. Then of course we need to have proper expertise of the modeling of heterogeneous and dynamic system, where we are going to integrate control, computing, and communication. For that, I have given you one example of my project, Scalable Energy Management Infrastructure for Households. Then we need to have the expertise from the system engineering point of view, or how we need to develop the cyber physical system. So here you can see that the theory is going to be the key component, and we are very good on that one. Okay, but that we need to integrate with the cyber physical system based laboratories also. Okay, and then why we want to utilize the cyber physical system based knowledge for making the products, right? So, but from the products also we need to learn what modifications we may need to have. So then in this education revolution 4, we need to do the product integration in the cyber physical system, and this cyber physical system integration need to be included into the theory, and then theory knowledge has to be provided to the cyber physical system, and this knowledge has to be provided to the development of the product. So that approach we need to use in developing our new education revolution 4 here. So if we consider our cyber physical system based academic system, so there is a lot of opportunities for different sections also. So the first section, which is a very key part and going to remain the key part forever, that is science and engineering foundations. So we need to have very robust and effective design and construction of systems and infrastructure, okay, for that purpose. Okay, then we need to have next approach to be system engineering or the integration approach. So how we can improve performance and quality assurance of computational and physical system. So for that, how we are going to redesign our course curriculums also. Okay, and then another very important thing is the applied development and deployment. So from this point of view also, we need to have effective and reliable system integration. And thank you.
Thank you, sir, for delivering such wonderful lecture. I hope all the participants have enjoyed and learned a lot from such a wonderful and knowledgeable lecture. Thank you, sir, for giving the opportunity and sparing the time in your busy schedule. I would like, whenever you visit the India, we will together visit to the Aryabhatta College Ajmer, so that your physical presence and physical knowledge sharing with the faculty members can also be arranged. Thank you, sir.
Thank you, Manish. It's my opportunity, and I'm looking forward to if the situation goes normal, right?
Yes,
And
yes.
whenever the situation becomes normal and I visit India, definitely I would like to come to Ajmer, and then with you and me, we can go together and discuss further opportunities, and maybe to have more interaction with the academic staff as well as with the students also.
Thank you, sir.
Thank you, sir, for such an informative session. Now, I will request our respected principal, sir, of ACRT Ajmer, Dr. S.C. Mathur, sir, to express the next.
Thank you, ma'am. Today's keynote speaker, Professor Munish Chandra Trivedi, sir. Today's resource person, Professor Mohanlal Kole, sir. Honorable Chairman of Aryabhatta Academic Society, Dr. Aryabhatta, sir. All attending faculty members and dear students. It is a matter of great pleasure to host this international webinar on cyber physical system. We are very thankful to Munish Trivedi, sir, for providing us an opportunity to listen from great academician, Professor Mohan Kolhe, sir. We are very thankful to Mohan, sir, for valuable time and enlighten us with his knowledge on cyber physical system and its physical application, practical application in different fields like Industry 4.0, smart energy system, and education revolution, etc. The topic is very emerging and advanced, so I am sure that all the participants will get benefit from this webinar. I also request to Mohan sir and Munish sir that kindly accept our invitation in future also and enlighten us with your knowledge and update us with this recent advancement in technology. To Computer Science Department for organizing this knowledge enhancing webinar. I again thanks to all participants for attending this webinar. Thank you very much.
Thank you, Principal Sir. I would like to thank our respected Director Sir, Dr. Amit Shastri Sir, for giving us such great opportunity. Now I would request all participants to ask your query, if any. You can put your query in chat box also.
Good afternoon, sir.
Yes, Ramesh Babu sir, you can ask now.
I would like to ask about cyber security. So, what are the tools or softwares required to face these cyber security problems? Can you throw a light, sir?
There's very that's broad questions. Need to have different softwares or let's say forget about software, different tools, and for each tools we need that domain knowledge. We have to how that system, right, has to be, or how that component has to be integrated within the system for a particular application, right? Based on that, we need to develop its algorithms, right, based on what type of operations we want. And that you can you use any type of different type of programming languages are used and like that, and then you can get it embedded into any system, and basically then that embedded system, right, is going to work as an IoT based system. So it is going to receive the information how we want to control, right, and then that information has to be included or for making some operation. For example, if you take a case of our mobile, right, so it has so many sensors, right, and it is considering all our information, and accordingly it is providing the output or something like that. So it is going to be a big, that's why I said that we need to change our education system considering this cyber physical system or industrial revolution 4. Thank you.
Thank you, thank you.
Thank you so much, sir. Participants, a feedback form has been shared in chat box. Kindly fill it to get your e-certificate, and it is mandatory for all. I would like to thank all the speakers who shared their precious knowledge with all of us. This event wouldn't have been successful without the members of organizing committee. Thank you so much for paying your valuable attention. Thank you, participants. Thank you all.
Thank you, Mohan sir. Sir, you can now. Hello.
Thank you.
Thank you, sir. Thank you. We will discuss later. You can now.
Yeah, I will log out. Okay, thank you.
Okay, thank you, sir. Thank you,
I'm
sir.
logging out.
Okay,
Thank you.
okay, thank you, sir.